Imagine looking up from Jezero crater and seeing a single, ghostly streak cross the Martian sky, a fleeting light that might be an interstellar visitor. On 4th October 2025, Perseverance's navigation camera recorded exactly that. The timing matches the predicted close pass of the interstellar comet 3I Atlas, and if it's verified, this could be the first time an interstellar comet was photographed from the surface of another world. Let's break down what was seen, how scientists are checking it, and why it matters. On Sol 1643, Alpha Force Oct 2025, Perseverance's right Navcam recorded a faint, elongated streak against a star-dotted sky. At first blush, it looks like a meteor trail, but Mars' thin atmosphere makes meteor streaks rare, and the image's timestamp coincides with 3I Atlas passing within tens of millions of kilometers of Mars. That perfect timing is why researchers instantly took notice, why the streak could be 3I Atlas, and why we must be cautious. Astrophysicist Avi Loeb and others have pointed out that the Navcam uses many short exposures that are stacked to improve low-light sensitivity. A bright object moving quickly across the sky will therefore appear as a continuous line in the composite image. Not because the comet is elongated, but because the camera integrated its motion over time. Loeb estimates the composite could represent roughly 10 minutes of motion, which matches the angular distance 3I Atlas would cover at its relative speed. Still, alternative explanations, a cosmic ray hit, processing artifact, or even a near-Mars satellite spacecraft glint, remain plausible. The coincidence of timing makes the comet hypothesis strong, but not yet definitive. What other eyes were watching Mars orbiters were watching too. ESA's ExoMars Trace, Gas Orbiter, and Mars Express turned their cameras and instruments toward 3I Atlas around the same time and recorded faint detections from orbit, the closest views we'd had so far from the Mars system. Combining surface images from Perseverance with orbital detections gives astronomers a precious parallax baseline to refine the comet's trajectory and speed. What telescopes from Earth and space are telling us. Meanwhile, powerful telescopes, Hubble and JWST among them, plus large ground observatories have been tracking 3I Atlas, coma, and spectrum. Early spectroscopy shows rich volatile activity, strong CO, CO2, and other gases, and unusual metal signatures that shift as the comet heats, hinting at organometallic volatiles driving changes in nickel-iron emission ratios. Those spectral fingerprints are key. If spectral changes seen by orbiters and space telescopes line up with brightness or shape changes from the Mars side image, the case strengthens dramatically. Why this matters: science and symbolism. If the streak is confirmed as 3I Atlas, we'll have the first direct surface-based observation of an interstellar object from another planet, a symbolic and practical leap. Practically, the extra viewpoint across tens to hundreds of millions of kilometers sharpens orbit solutions, helps constrain rotation and coma evolution, and ties spectral chemistry to how the comet appears from different vantage points. Symbolically, it shows rovers and orbiters doubling as a distributed interplanetary observatory network, turning our solar system into a multi-point lab for transient astronomy. What scientists are doing right now: teams are cross-checking everything. Navcam metadata, pointing, exposure times, and image stacks, orbital instrument logs from TGO, Mars Express, and ground space telescope spectra and imagery. If the direction, motion, and brightness profile in the Navcam composite line up with orbital detections and spectral changes, the comet ID will be strong. If not, the exercise still pays off. It improves how we calibrate long exposure, stacked imaging on Mars, and helps future transient detection pipelines avoid false positives. Counterpoints and open questions. Some analysts note the streak's CS apparent angular speed may be faster than a comet at that distance should appear, which opens the door to other possibilities: satellite streaks, image processing artifacts. Papers and posts from independent researchers have already debated these points, and mission teams will need to publish careful, time-tagged cross-checks before the science community can reach consensus. Whether the Navcam streak is Three-Eye Atlas or an interesting false positive, the episode is a milestone. Robots sent for geology are already doing astronomy, forming a lightweight multi-world network that can catch fast, rare events. Every image and spectrum we gather helps us map how matter behaves across the galaxy, and this one streak has pushed that idea into sharp relief.